So good afternoon everybody, myself Acharya Vishvendra. Let's discuss some of the graphs based on kmax and lambda. So we have discussed that kmax is E minus phi naught. So kmax is h nu minus phi naught, which gives kmax is hc by lambda minus phi naught. Now if we draw graph between kmax and lambda, we can say that as lambda tends to 0, kmax will tends to infinity, and at lambda is equal to lambda naught, kmax is 0. So obviously graph will be rectangular hyperbola like this, and it will be having the coordinates as shown. Now suppose there are two graphs. So as we can see in the graph, lambda naught for B is greater than that of A, which means work function will be in the inverse order, and similarly the threshold frequencies. So in this way we can solve this question. Now there is one important note that threshold wavelength of a metal lies in visible light, then photoelectric effect is possible with UV, X-ray, gamma ray, but not possible with infra, micro and radio because of the frequencies. As we know that for photoelectric effect, energy of the EM wave should be greater than the threshold frequency. So visible light, if we observe the pattern of electromagnetic waves, it is visible infrared, it's radio waves, microwaves, infrared, light, UV, X-ray, gamma rays. So as we move downwards from light, then all the EM waves which lies down, which are just below the light, which includes UV ray, X-ray and gamma ray, can cause photoelectric emission, but that EM wave which lies above the light, visible light itself, will be unable to do the photoelectric effect. Next observation is that if a photon of energy equal to the work function is incident on a metal surface, then kmax will be 0, and if frequency of threshold or wavelength, then also kmax will be 0. It's very clear from the photoelectric equation. Then another concept is that of stopping potential. It is observed that when photocurrent can be made 0, if we apply a certain minimum potential in such a way that collector is negative with respect to the emitter, so that is called the stopping potential. So we can say that stopping potential is equal to the magnitude of k max is equal to E into magnitude of stopping potential. In that way we can calculate the potential difference. Suppose that this is the emitter and this is the collector, and you incident certain photons here, as an impact of which photoelectrons are emitted. We assume that here voltage is 0 volt and here voltage is minus V0.